Hello everyone, welcome to Physics CQ-METANS. This is the first video lecture on vector analysis. So these are the topics I will be discussing in this video. So we'll start with the definition of a vector and then we will see law of vector addition, in which I will discuss the parallelogram and the component form of vector addition. So, defining a vector. Before we go into this, let us see couple of examples. So let's say I have an object and I want to measure the temperature of the object. So the parameter is temperature of an object. Now I use a thermometer and just measure the temperature and I get the temperature as 40 degrees Celsius. So this is just a number. Now suppose I have another example. Let's say I have a point A and I have a point B somewhere over here. So these two points are separated by a distance, let's say by 2 meters. Now there is a person sitting at point A and at point B. Now the person who is sitting at point A wants to displace an object to a person sitting at point B. So this is the direction in which he will displace or push the object so that it will reach to the B. Now in first example, I measured the temperature. So I got just 40 degrees Celsius. There is no direction dependent. So such quantities in which only we talk about the magnitude are called as scalars. Scalar quantities. While in second example, now direction is important. Magnitude is important, but the direction is also important. Suppose the direction is not given. Suppose this A has just told that pass this object. So in what direction? That is not specified. So magnitude as well as direction where it is involved is called as vectors. So vector is a quantity that has both magnitude and direction. So magnitude is represents the size or the length of vector. It is just a number, typically a positive value, and direction indicates the orientation of vector in space. Now suppose this I take this axis as x-axis, x coordinate. So the displacement is from A to B, that is along the x direction. So this is the orientation of vector in this space, in this coordinate system. Now this point is very important, that vector should obey the law of vector addition and multiplication. Just if it has a magnitude and direction, is it a vector? The answer is no. Because just take an example. See, I am writing this line. Vector should obey the law of vector addition and multiplication. I am writing this line. So what is the magnitude? Magnitude is number of birds in that line. And what is the direction? I am starting from writing from left and going on to the right. So left to right is the direction. So is it a vector? The answer is no, because we will see it will not obey the law of vector addition and subtraction, multiplication. Next, vectors are used to represent physical quantities which has magnitude and direction like displacement, velocity, force, etc. So the example which we talked over here is the example of displacement. Next, I would like to make few comments. So as I mentioned, not every physical quantity which has magnitude and direction are vectors. So here are few examples. So current. Now we know that current has a conventional direction which is opposite to the flow of electrons. So see, if I have this current I1, this is another current I2. The angle between them is say theta. See I1, let us call it as 3 amperes, and I2 let us call it as 4 amperes. So 4 plus 3 is 7. So this is I3, we get it as 7 amperes. So now even though this current has magnitude and direction, but they are not adding vectorially, they are just adding by this Kirchhoff law. According to the Kirchhoff's law, they are getting added. Like we will see that if I have a vector, then their components get added, but here there are no components. If I1 would have been in this direction, still it would have added in this way. So Kirchhoff law is governed over here. So the current we will classify it as pseudoscalar. Then just to make comments, magnetic field, angular momentum are pseudovectors, while volume element is a pseudoscalar. So what is this pseudoscalar and pseudovector? We will see that. We will see when we will study tensor analysis. So in the tensor analysis, we will cover this point, but still briefly I will discuss what the pseudovectors and pseudoscalars are in the upcoming videos. Now next we move on to the representation of vector. Now if I have a vector, I mentioned it is oriented in space. So how it is orientation? What its orientation in space? Let's see. So in 2 dimension. Now this is my 2 dimension Cartesian coordinate system, the x and y coordinate system. Now this is my vector A. Now this vector A has a component along the x-axis. We call it as Ax. Now what is this component? It is the projection of the vector A along the x-axis. What is projection? So it is simple, just to explain I'm doing this. So if this is a torch, so if I put it, the shadow of this vector on the x-axis is nothing but the projection of that vector on the x-axis. So this is the component of this vector A along the x-axis. Similarly, if I take the projection of this vector A along y-axis, so we will call it as AY, the component of this vector A along y-axis. Now I need to define the direction. So there is something called as unit vectors. So along the x-axis, I will define a unit vector I cap, and along the y-axis, we will define a unit vector j cap. Now what is a unit vector? It has the magnitude 1. So in 2 dimension, the vector A is represented as this vector A. So vector is represented by that letter and an bar or arrow on head of it. So A, vector A is equal to the component of vector A along x-axis in the direction of x, similar plus the component of vector A along y-axis in the direction of y. So this is how n vector is represented. Next is the length or the magnitude. Now suppose I am interested in only finding the magnitude of that vector. So in order to do that, let's see. So if I complete this triangle, so this becomes a right angle triangle. This component, if this is Ax, this component also becomes Ax, and this becomes Ay. So by Pythagoras theorem, if this is a right angle triangle, if I apply Pythagorean theorem, I will get magnitude of A square is equal to Ax square plus Ay square. So if I take square root on both the sides, I will get this equation. So this is the magnitude. Similarly, what I can do is I can extend it to the 3 dimensions. So in 3 dimensions, I will have Ax, Ay and Az. So if I have the Z component, Z axis coming out like this, so there will be an Az component on along this Z axis. So we will write in 3 dimensions this vector A as Ax I cap plus Ay j cap plus Az k cap. Now similarly the magnitude of This vector in 3 dimension is given by square root of ax square plus ay square plus az square. Now addition of vectors. So there are two ways. So method one is parallelogram and another is the component. Now in parallelogram of vector addition, first let us see how we draw a vector. So vector is drawn in this way. So this arrow is called as the head of the vector. This is the head of vector and this is the tail of the vector. Now in order to add two vectors, now suppose if I have two vectors A and B and I want to add them. Now see over here the notation is capital A and capital B. So capital A, sorry, this bold faced A and bold faced B is, I'm writing it as vector. Sometimes I write it as A and arrow on top of it, but in textbook the convention is this bold faced. So now if I draw this vector A like this, and if I want to add A and B, these two vectors A and B, what I will do is I will take the B and place the tail of the B at the head of A. So this is how we will draw. So see, the head and the tail of B are aligned. So, and then I will draw an vector starting from the tail of A to the head of B, and this vector we call it as vector A plus B. So graphically we have represented it over here. So this is vector this is vector B, and this is the vector, the red line is vector A plus B. So this component is AX and this component is BX. So this is the representation. So this is the parallelogram of vector addition. So it can be asked graphically, show what is vector A, 2A, 3A, 2A minus B, and etc. We will solve that problems. Next method is adding components. So the second way of finding A plus B is to add components. Now from the graph we can see that this is A plus B, but this is AX. So this line is AX, then this one is BX, this component is BX, and the entire line over here, this entire line is A plus B. So if I see the X component, it is AX plus BX. Similarly over here, this is BY, this is AY, and this entire becomes AY plus BY. So that is what we are saying. So A plus B, we have to add the components. So I will just write here. So this vector A can be written as AX I cap plus AY j cap. There is a plus sign between BX I cap plus BY j cap. That is equal to, so I cap, the direction I keep it same. So the component get added, AX plus BX plus j cap AY plus BY. So if you notice, the components of the vectors gets added when I add two vectors. So this is the adding of components. Next is law of vector addition. So law of vector addition is commutative. Commutative means if I do vector A plus vector B, or if I do vector B minus plus vector A, it is one and the same. So this operation is true. Next is associative law for vector addition. Associative law means what? If I have three vectors A, B and C, so what I can do is I can add A and B and then add C to it, vector C to it, or I can add B and C first and then A to it. So the parenthesis, this bracket, is solved first. So over here this In the bracket I have a plus b, so I will first do a plus b and then add c to it, and over here I will do first b plus c and then add a to it, and the results will be same. I can also do it as a plus c plus b, and still it will be same. So this is the associative law for vector addition. Next is negative of a vector. Negative of a vector means the vector has same magnitude but different direction, opposite direction, not different but opposite. So the vector has same magnitude but opposite direction. So it is represented by a minus sign in front of it. So over here we have graphically represented. So this is vector A, this is vector B. Now see the vector B, negative of vector B, it is has the same magnitude but it is in the opposite to this B vector. So for instance, if this is my vector A, so the negative of vector A will be the same magnitude but in the opposite direction. So I will call it as minus A. Now the components also I have drawn over here. So this A, so this component is the AX component. Then from here to here it is BX. So if I add this two, I will get this A plus B. And if I subtract this two, so this one I will get it as A minus B. So this the X component. So seeing A minus B means the sum of two vectors A and the negative of the vector B. So if you notice, if you remember, in the first video I have discussed that I have written subtraction in bracket because subtraction is nothing but the addition of the negative vector. So now each component of A minus B can be obtained by subtracting corresponding components as we have seen in A plus B. So still if we do so over here, so it will be this A vector can be written as AX I cap plus AY j cap minus BX I cap plus BY j cap. So that is AX minus BX I cap plus AY minus BY j cap. So this only the components get subtracted. So like addition, subtraction of vectors can be done geometrically, which we have done over here. The components you can just see. So this component, if you just notice, this is the component of this. So this component will be AY and this component will be BY, and particularly you can just check this. Now next is a zero vector. Now zero vector can be obtained by adding a vector and its negative. So vector and its negative, if we add, we get the zero vector. Or another way of getting a zero vector is adding with a scalar. So this C over here is a scalar. So if C is 0, then the vector becomes a zero vector. Now vector of a 0, so 0 vector has a magnitude 0, all its components have 0 and it does not have a direction. Important is this, it does not have any direction. So that's it for this video. So in the next video I will discuss about the vector multiplication, I will discuss about the scalar product and the vector product, that is dot and cross product. So thank you all. Thank you for joining me. So see you all in the next video. Thanks a lot.